So if we put the x values into list 3 and the y values into list 4, or any of the lists you want, we would see the scatter plot by going back to stat plot, second y equals, pressing 1 to select plot 1, making sure it's turned on and scatter plot is selected, and making sure the correct lists are entered for your x and your y. My x data was in list 3, so I pressed second and then the 3 button to get that. My y values were in list 4, so I pressed second and the 4 to get that. Need to press zoom again and choose 9. So the scatter plot we'll see there. We could sketch into the notes. And it looks like from what I'm seeing there, the dots are pretty scattered, so I would probably say there is not a correlation, no correlation. Since we don't see a strong trend upward or downward, remember that what we have on the x-axis are the heights, the x values, and what we have on the y-axis are the IQ scores. And a good title would be Y versus X, like IQ score versus height. So it does not look like a relationship between those points. I don't see a line upward or downward when I look at the dots. So we've been talking so far about looking at the scatter plot and describing what we see. We can determine for sure if there's a correlation or not by calculating the correlation coefficient. The letter R stands for the correlation coefficient. Sometimes you'll hear it called the R value. So this correlation coefficient measures the strength and the type of linear correlation. It'll let you know if there is one or not when we compare it with some values on a table on the next page. The calculator is going to compute these numbers for us. The correlation coefficient can range anywhere from -1 to +1. A correlation coefficient, or R value of +1, would indicate a perfect positive correlation. To be honest, we're not likely to get exactly that. We're likely to get some kind of a decimal, and it might be pretty close to 1, which would let us know that there's a strong or a very strong positive correlation. On the other hand, if it was not so close to 1, if it was closer to 0, that would tell us there is not a correlation. 0 is the worst possible R value. 0 would mean absolutely no correlation, and anything close to 0 would also be no correlation. On the other hand, if the R value came out to be -1, that would indicate a perfect negative correlation. So it kind of flips around and starts being good again as the R value gets closer and closer to -1. We're still unlikely to see that exact R value, but what we want to keep in mind is the closer to -1 it is, the stronger it is. So anything in the -0.9, maybe even the -0.8 range, would be a strong negative correlation. These are going to be decimals, so they'll need to be rounded. Most often they're rounded to 3 decimal places. And when we start to wonder what the cutoff is, like how close to 1 does it need to be significant, or how close to -1 does it need to be significant, that's where the table on the next page comes in. It helps us know if we really do have a correlation or not. So what we'll see on the table on the next page is this depends on how big the sample is. This one up here, for instance, we had 1, 2, 3, 4, 5, 6, 7, 8 data points. N equals 8. So on this table on the next page, we would want to come down, on the next page, we would want to come down under N to 8. So here's the N values, here's N equals 8. And then look next to it. These values will let us know how close to 1 the correlation coefficient needs to be. There's 2 columns because we can be more or less sure. This 0.05 would be like being 95% sure whereas 0.01 would be more like 99% sure. In the problems we see, they typically ask us to use 0.01, so I think you can pretty safely disregard this column and just focus on these numbers. So here's how it works. The correlation is significant when the absolute value of R is greater than the value in the table. So we're going to use our calculator to find this R value. If we strip off the sign, in other words, look at just the absolute value of the number but not the sign, if it's bigger than the number from the chart here, then we know the correlation is significant. So in other words, these are letting us know how close to 1 it needs to be significant. And notice the smaller the sample, the closer to 1 it needs to be. As you have a bigger sample, in other words, when you have more information, you don't have to be quite as close to 1 because you know more about the situation. On the next page, we get a chance to try out using the correlation coefficient, using the chart. So you'll see that to get started, this is the same couple of steps. We need the data in the lists, and we still press Stat. But we're not going to stay on the Edit menu this time. We're going to arrow over one time to get to the Calculate menu. As you move, the options change. So once you're on the Calculate menu, next to number 4, you'll see LinReg, which stands for Linear Regression. So let's use that to find the correlation coefficient for the first data set we looked at in this section, where we had the ages and the number of words for children. The data might still be in list 1 and list 2. If it's not, you could just pause for a sec and type them in there. It looks like mine still is. So data is in the list. I'm going to then press Stat, arrow over to the right once to get to Calc, and then choose number 4, Linear Regression. Some calculators will give you prompts like this. It wants to know where the X values are and where the Y values are. My X values were in list 1, so I need to change that so that it says L1, and my Y values were in list 2. If you used any other lists, here's where you let the calculator know. And then you come down to Calculate, press Enter. If your calculator does not give you the prompts, it might look more like this one. So we still put the data into the lists, we still press Stat, go over to Calc and choose option 4. However, this one just brings the command back to your home screen. So what we want to do in that case is put the lists that we're using right after the command with a comma in between them. So if I want to use list 1 and list 2, I need to press second and 1 to get the L1, and then I have a comma button here just above the 7. Then second and 2 to get L2, and enter. So should have the same results on either calculator. If you're not seeing the R and the R squared, that's because the diagnostics are not turned on. You might go back to the beginning of our 9.1 video and see how to turn on your diagnostics. The number we're looking for here is the very last one. And we said it's typically rounded to 3 places, so let's round that off to 0.979. Then let's notice how many data points we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. N equals 11. That will help us when we are using our table. We want to come down to 11 under N and then look straight across. So this R value needs to be 0.735 or higher in order to be significant. 0.735, let's write that down here. Okay, so we said the absolute value, which doesn't change it because it was already positive, needs to be greater than the number from the table. And it is, it's well above that. So that helps us know for sure that yes, we do have a strong, or maybe you'd like to say very strong, positive correlation. The next one down here works the same way. This data is what we put into list 3 and list 4 earlier, so you might have it in there. This would be a good time to press pause on the video, see what you get for the R value from the calculator, see what number you get from the table, and see if you can prove what we saw in our scatter plot. So I have the data in the lists already. I'm going to go to Stat and Calc. Choose number 4 for linear regression. Tell the calculator I'm using list 3 and list 4 this time. And it looks like the R value is 0.051 when we round it to 3 places. That's really close to 0, so I don't think we're going to have a number of the table showing us a correlation, but let's just check and make sure. We had 1, 2, 3, 4, 5, 6, 7, 8 data points. So this is the one we were looking at a little earlier where there were 8 pairs of values. In order for that correlation to be significant, it needs to be 0.834 or higher. N equals 8 gave us 0.834. So thinking about the absolute value, looking to see if that's greater than the number in the chart, and it's not. This is way too close to 0. Just as we suspected, there is no correlation. So on the next page we have a full problem involving everything we've looked at so far, starting with a new data set, drawing a scatter plot, describing what you see, finding the correlation coefficient and the number from the table to prove if there's a relationship or not. Push pause and try filling that all in, see if we get the same things. So here's the scatter plot I got, and that again came from putting the data into the lists. I happen to use L5 and L6, going in to make sure it knows what lists to graph. Scatter plot is still turned on. Then to zoom and 9 for zoom stat. Definitely have a negative direction to the points there. It looks like a perfectly straight line, and then there's an abrupt turn and another perfectly straight line. If we're looking at it all together, there's definitely a negative pattern. Not quite perfect because of the bend, but definitely a strong negative look. The calculator gave me a correlation coefficient of negative 0.986. I want to strip off the sign and just consider the value. So absolute value of that compared to the number from the table. This had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. So we're thinking about n equals 10. And that was 0.765. 0.9 is definitely greater than 0.7, so we do have a strong negative correlation. Something to keep in mind is just because the variables are related doesn't mean one directly causes the other to act a certain way. It could be a direct cause and effect relationship, or maybe it's backwards, maybe it's not exactly what we think. Or possibly there are other variables causing them to be related. Or maybe we just happen to find some data that looks like it has a relationship, but it's really just a coincidence. So just to keep in mind, because they're correlated, doesn't always mean that one directly causes the other.